Good morning, guys. Good afternoon, good evening. Now let's talk about organic chemistry. Um, I'll be discussing like four or five of those, like the Alkanols, the Alkanals, Alkanon, the Alkanoates, and the Alkanoic. So those are the ones I'll be discussing today. So now starting with Alkanols. Alkanols. Now, without wasting much of our time, they have a general molecular formula of CnH2n plus H2n plus 1 OH. So let me write the plus very small. We have Cn H2n plus 1 OH. Can refer them to as this ROH, where the R is an alkyl group and the OH is the functional group. The R is an alkyl group, can be methyl, it can be ethyl, it can be propyl, it can be butyl, whatsoever. The OH is the functional group of the alkanol. So now let's quickly move to the classification. The classification. So alkanol can be classified based on two types. You can classify them based on the numbers of OH they have. You can classify them based on the position of the OH they have. Now, based on the numbers, if you only have one OH in the compound is known as monohydric alkanol. For instance, if you have COH, you have hydrogen, 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 hydrogen. Because this one have one hydroxy group, OH. So this is known as monohydric alkanol. Monohydric. If you have two OH, that one gives you dihydric. If you have something like this, we have OH, are we together? So this hydrogen, hydrogen, hydrogen. So this one give you a dihydric alkanol, dihydric. So if we have like three in form of this CCC, then hydrogen, then you have your OH, your OH, your OH, or this one can be hydrogen or whatsoever. So this one contains three OH. This one is known as trihydric. Trihydric. I think a trihydric alkanol is known as a glycol. If I'm not mistaken, it's also called a glycol. Some books call it, like, based on number, they only have mono, di, and poly. Where in that polyhydric we have tri. But I'll just do it based on four. Because for this tri, it has a particular name which is a glycol. So let's have mono, di, tri, then let's have poly. Polyhydric. Polyhydric. So we can have a form of that is more than three. Are we together? So you have your OH. Here, let me put CHO. Then you have another OH here. Then you have another OH. Then you have another OH. Then maybe you have this one. Let me say CH2OH. Are we together? Then you have C. You have C. Yeah, I think that should be. Then you have another. Let me say this H. This is an example of polyhydric. More than three OH. One, two. I can put this one this side. It doesn't mean. H. So in form of this, for this particular polyhydric now, I think this should be glucose. Yeah, that's glucose for this particular. So glucose is an example of alkanol. Are we together? So that's that for that. Now that's based on number. Now based on position, they are grouped into three. This is based on number of OH that we have. So when we have one OH monohydric, when we have two di, when we have three tri, when we have more than three, four or more, that's poly. Now based on position, classification based on position. That one can be grouped into three. We have the primary alkanol, we have the secondary, and we have the tertiary. So the primary alkanol is when the OH group is Attached, let me write something. See, okay, let me just write everything so that you understand. Oh, maybe I have under C here. This one I have C. I have, let me make it 4 for for better understanding. Yeah, yeah, I think this is enough. Let me make it 4. OH. This one maybe I now have C, C. And I have maybe I have OH. Coming. Yeah, maybe I now have another a Q group here. Yeah. Let's say all these ones are hydrogen. Let's say all these ones are hydrogen. So when the OH, the carbon attached to the OH, are we together? If that carbon attached to the OH, if the carbon is directly attached to only one carbon, normally the carbon that are attached to this guy, they are more than one, two. Even though this one is directly attached to this, but we can still say these two are connected to this, even though not like indirectly. Indirectly, this one is connected to this, but we're talking of direct attachment. The carbon attached to the OH, if that carbon attached to the OH is only directly attached to a single carbon, those that are here are not single. This H, I'm having all this dash, I'm having H there, they are not carbon. So this guy now, this carbon that is carrying the OH is directly attached to just a single carbon. So when the carbon that is carrying the OH is directly attached to just a single carbon, it's known as primary. But for this one, when the carbon that is directly attached, when the carbon that is attached to the OH is directly attached to two carbon, you can see that carbon attached to the OH is directly attached to this, is directly attached to this. When it's directly attached to two carbons, it's known as secondary. But for the tertiary, when that carbon attached to the OH is directly attached to three carbon, you can see this guy is directly attached, even though if you have more. But so far that it's only directly attached to this one, directly attached to this two, directly attached to this, that's three. So such is known as tertiary. Are we together? The carbon carry the OH. If that carbon is directly attached to another single carbon is primary. If that carbon carry the OH is directly attached to another two carbon is secondary. If the carbon carrying the OH is directly attached to another three carbons is tertiary. Are we together? Now let's move to the preparation of alkanol. So we have two methods of preparation. We have the laboratory preparation, the lab, and we have the industrial preparation, the industrial. Another name for the industrial preparation is also called fermentation. Fermentation. Are we together? So now, for the lab preparation, we use it to prepare alkanol. Another name for alkanol, you can also call them alcohol. Let me not skip that. You can call them alcohol. Let me say alcohols. So the lab preparation, we prepare them in small quantity. When, let's for instance, when 18 C2H4, 18 plus H2 gas, H2O rather, H2O gas. So H, whenever I see gas attached to H2, that means steam. Steam. Are we together? That's steam. You don't put L for steam. We put gas. To give us C2H5. Are we together? OH. I think that's completed now. Then this one will be liquid. Yeah. In the presence of H2SO4. In the presence of H2SO4. So please take note, that's the catalyst needed for the industrial for the laboratory preparation of ethanol, of alkanol, of which an example is an ethanol. So when 18 is when you add 18 and steam together, it will give you ethanol. Or let me say when you have alkene and steam, it will give you alkanol. An example of alkene is the 18, and an example of the alkanol is the ethanol. Are we together? So we use this lab preparation to produce them in small quantity. But for the industrial preparation, which is also known as fermentation, you can have that's the breaking down of starch. Starch, first giving us maltose. Can have it in this form. Then from maltose, we can have glucose. Can have glucose. I'm sorry, let me zoom. Yeah, we can have glucose. From glucose, then we can have ethanol. Please always take note. The byproduct, should I call it byproduct now, of fermentation is CO2. CO2. Keep it at the back of your mind. CO2. So when starch is broken down in the presence of a catalyst, organic catalyst to be precise, organic catalyst, let me that should be a dietase. A dietase is gotten from malt. Are we together? That's an organic catalyst to give us maltose. Are we together? Now, this one, another organic catalyst, maltase. Maltase is gotten from yeast to give us glucose. Are we together? So the catalyst here, I think that one should be zymase. Yeah, zymase. Zymase also is gotten from yeast. Those are organic catalysts. Then we get our ethanol. Are we together? This ethanol is in large quantity. You can have N here. N, that N can represent 2, 3, 4, 5. Are we together? That is the industrial preparation. We produce it in large quantity using industrial preparation. But when we need small quantity, that's what we call the lab preparation. Or you can also have it this way. You can have sucrose. Sucrose directly to give us in the presence of invertase as an organic catalyst. Invertase, which is gotten from yeast. Yeah, invertase is gotten from yeast. Are we together? I'm sorry for my writings. The tip of the pen is somehow. Then to give us glucose, I will try and adjust the writing. To give us glucose, and in the presence of zymase, which is also gotten from yeast. Zymase, which is also gotten from yeast, to give us ethanol. Ethanol. Please don't forget CO2. Don't forget the CO2. This ethanol too is in large quantity. It's in very large quantity. So that's the method of preparing um alkanol. Are we together? So another thing, we are moving to the properties now. Properties. Properties. I will do another video on the nomenclature, but today I'll just be dealing with all these essential aspects which you need to take note of. So properties now, they are the first one, they have a boiling point of 78 degrees Celsius. So normally it shouldn't be high up to that extent. Boiling point of 78 degrees C. It shouldn't be up to this extent. Are we together? But the reason being that it contains OH, which make a bond with the hydrogen in water. Are we together? So that's why we have a boiling point of 78 because of the hydrogen bond. So that's one. And that another one, they are also neutral to litmus paper. They are neutral to litmus paper. That is, they are neither basic nor an acid. Are we together? In either turn blue litmus paper red nor red litmus paper blue. Another one is the oxidation. Another property is oxidation. They have an oxidation property. Another one, we also have esterification. It's also a property, esterification. And we also have dehydration, the fifth one. We also have this dehydration. So now let's talk about the properties of oxidation. Now, we oxidize alkanol to give us some particular compounds too, some particular organic compound. But it depends on which types of alkanol we oxidize. If you oxidize primary alkanol, I've differentiated what primary alkanol is initially. If you oxidize primary alkanol, we get alkanal. Another word for alkanal is aldehyde. If we oxidize secondary alkanol, we will get alkanone. Another word for alkanone is ketones. So the properties of an alkanol is oxidation, which makes us to be able to produce another organic compound using alkanol. So now, if you are to oxidize alkanol, ROH, are we together? ROH, in the presence of catalyst. The catalyst can be permanganate MnO4 minus, or it can be um, Cr2O7 H plus. Now, when we are talking of oxidation, let me move back to the oxidation. Oxidation depends on it has a lot of definition, depends on which time you are referring to. We have oxidation to be what? Loss of electron, while reduction is gain of electron. Oxidation in terms of oxygen, oxidation is addition of oxygen, while reduction is removal of oxygen. In terms of hydrogen, oxidation is removal of hydrogen, reduction is addition of hydrogen. In terms of oxidation number, oxidation is increase in oxidation number. In terms of electronegativity, oxidation is increase in electronegativity. In terms of electropositivity, is decrease in electropositivity. So now, removal of hydrogen, that's also oxidation. Addition of oxygen, that's also oxidation. So let's just move on. So this Cr2O7 minus. So we want to oxidize ROH. It's going to give us RCHO. Are we together? This is known as partial oxidation, because if we do a complete oxidation, we are going to get, if you oxidize this guy again, we are going to get Alkanoic. For instance, if we oxidize this again, we are Cr2O7 minus, this one is going to give you RCOOH. Are we together? You are going to get alkanoic acid. Am I communicating? So let me just write structure for us to just differentiate. Just tell us what we need to see. Primary alkanol. Please take note. Primary alkanol. So let me start using butanol. So we have C C C C O H. Is the AOH is only directly attached to one, and the carbon attached to it is only directly attached to another one, just one carbon. That's why it's primary alkanol. So you have this, 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 this. Those are hydrogen. Are we together? In the presence of this guy, catalyst, and communicating is going to give us C, C. Then we are going to have another C. Then we have C. Then we have O. This one is Alkanal. Alkanal. Are we together? Yeah. You have Alkanal. These are H, H, H. You cannot put another H here because the bond that must be bonded with carbon must not exceed 4. You have 1, 2, 3, 4. I will still talk about Alkanal. Why am I putting the whole here? I will still talk about it. Just know it's going to give us an Alkanal. Now, if we oxidize this guy again, we are going to get Alkanoic. From butanol, the oxidation of butanol to give us butanal, the oxidation to give us butanoic. We have C, 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 C. Are we together? So here we are going to have O, then OH. We know alkanoic is in form of RCOOH with one of the O to be double bond. Are we together with the carbon? So that's the oxidation aspect. So please take note. That one is primary alkanol, oxidation of primary alkanol to give us the partial oxidation to give us alkanal, while the complete oxidation to give us alkanoic. Don't forget this. It can either be KMnO4, it can either be MnO4 or Cr2O7. Am I communicating? So the difference is that when you use, what's it called now? Okay, we still get there. Now let's just talk about and the secondary alkanol. The secondary alkanol, the oxidation of the secondary alkanol. Secondary alkanol, you can have it in form of CCCC. Then here you have your OH. You can see the carbon attached to the OH is directly attached to two carbon. So those are examples of secondary alkanol. So you have your hydrogen, hydrogen, or whatsoever except carbon. Are we together? No, for now, they are hydrogen. Sorry, hydrogen. So in the presence of Cr2O7 minus, are we together? So the oxidation, so here we are going to have, it's going to give us Now you are removing OH from here. Just chain the OH with double bond and put O. Am I communicating? So this the oxidation of secondary alkanol. Hydrogen, 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 hydrogen. The oxidation of secondary alkanol will give you alkanol ketones. Now the difference between the alkanal that we got the other time and ketone is that actually their difference is that they have the same functional group. They have this COO, whereby the carbon is attached with a double bond. Are we together? No, is it this? Sorry, not this. Yeah, this is what I want to draw. Something like this. Yeah, the carbon attached, the oxygen attached to the carbon with a double bond. So alkanal have this functional group. Alkanon to also have the functional group. But the difference between alkanal and alkanol is that alkanal, the C double bond to O is at the terminal. Like this. It's at the terminal. You can see. It can be on this end or on this end. It's at the terminal. But for the alkanol, which is also known as ketone, is at the middle. Are we together? It's at the middle. It can be here or here. Once it is here, it's now, no longer non. It's alkanal, no longer alkanol. But the fact that it's at the middle, because it is secondary alkanol we oxidize. And for secondary alkanol, the OH must be directly attached. The carbon attached to the OH must be directly attached to two carbons. So the product that will be given must be in the form of, that's for you to just remember, must be in the form such that the carbon attached to the double bond O must be directly attached to two carbon. Do you get? But for this one, because we are using primary alkanol, yeah, because the OH is the carbon attached to the OH is directly attached to just one carbon. So the product alkanal given, the carbon that will be attached to the double bond O must be directly attached to just one carbon. That's the idea. Just change the position of OH. Put O with double bond. Primary, just like primary, but this another name. This just like primary alkanol, but there's nothing like that. This alkanal, but do you get the idea of what I'm saying? This like secondary, this like um maybe let me say secondary alkanal, but there's nothing like that. This alkanol, but just use that idea. Do you get what I'm saying? Secondary alkanol oxidation to give you alkanon or ketones. Why the oxidation of primary alkanol to give you alkanal aldehyde. So that's that for that. Now we move on to um we also have what's it called, the esterification aspect. So we have alkanol plus alkanoic. I gave you many properties the other time: boiling point, reduction, oxidation. So here now we are moving to the property of esterification. So we have alkanol plus alkanoic to give us esters plus H2O plus H2. You know another word for esters, they are the alkanoates. Are we together? Alkanoate, and they have sweet smell, sweet smells. Are we together? So these have in form of ROH plus RCOOH to give us ester RCOOR plus what? H2O. Are we together? Now let's draw a structure. And please take note, the esterification is a reversible reaction. It's a reversible reaction. Are we together? It's a reversible reaction. So let's draw a structure using ethanol. Ethanol is CH3CH2OH plus propanoic acid. Propanoic acid to be maybe let me say CCCOH double bond with O, RCOH. That's 1 to 3, 3 carbon propanoic acid to give us I told you it's a reversible reaction, to give us ethyl ethanoate. ethyl ethanoate in the form of one, two, then this third carbon double bond with O, then we have C and C plus H2O, hydrogen, 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 hydrogen. So now the double bond, the O here, am I right? Yeah, sorry, there is another O here, double bond. Then we have O, then the O is attached to this C. Are we together? One of the O has a double bond with C, and the other one have it can be up here. The O, this double bond can be down. Another one has a single bond with C. So all the carbons that are attached to the O with a single bond will be named in the form of alkane. While the carbon that all this one on this side with the double bond will be named in form of noate. So like this one, since we have two carbon, this ethyl in the form of alkyl rather, not alkane. Ethyl propanoate. 1, 2, 3, that's propane. Ethyl propanoate. Like all those parts that is attached to the oxygen with single bond with carbon will be called alkyl. So ethyl, alkyl or alkyl, ethyl. So all the part that is attached to the oxygen with double bond with carbon will be called noate. So this is not propyl ethanoate, this is ethyl propanoate. That's how to name esters. So those parts, you can see it in form of this. You can see maybe C, 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 this one, CH2, CH3. So, oh, sorry, there is O. I'm sorry. Why do I used to forget this O? So we have this O. Oxygen must not exceed double bond. We have one here, one here. But this one, since there is nothing attached to it here, all the double bond it needs is attached to the carbon. So the part that is only attached with oxygen by just single bond, single to carbon, single to this, those parts will be called a alkyl. So this is ethyl. If I have another carbon, it will be propyl. So those parts here that are connected to the double bond of oxygen will be called the noate. This is ethyl propanoate. So when we are doing nomenclature, we emphasize more on that. Are we together? So we also have dehydration. Dehydration, the other property I told us, dehydration. So dehydration, let's say we have C2H5OH. Then in the presence of conc H2SO4, conc H2SO4, are we together? Dehydration, like we are removing water, minus H2O. We are removing water. So that one is going to give us 18. Are we together? Take note, under high temperature. Those are the things you need to take note. Under high temperature, before I forget, under high temperature, in the presence of excess H2SO4, excess conc H2SO4, under high temperature, and excess H2SO4. So if you have excess H2SO4 under high temperature, ethanol will give you 18 by dehydration, by removing water. But if you have excess ethanol, maybe you have excess ethanol, something like maybe 2C2H5OH, and you just have H2SO4. Are we together? Then it's going to give you, instead of it under lower temperature, under low temperature, low temp. So instead of this one, normally to give you C2H4, this one is going to give you, what's the name of this guy? It's going to give you a causing C2H5OC2H5 plus water. So normally, instead of it to give you C2, but it depends. If you have excess H2SO4, conc H2SO4 to be precise, under high temperature, ethanol or alkanol will give you alkene. But if you don't have excess H2SO4, maybe you now have excess alkanol, it may be ethanol. Under low temperature, it won't give you alkene. It's going to give you alkoxy plus water. This is ethoxyethane. Are we together? So that's that for that. Now let's move on. So they are used as fuel. They are used as an antifreeze. Uses of alkanol. They are used in alcoholic beverages. You know they are alcohol. Alkanol, alcohol. They are used in alcoholic beverages. They are used as solvent. They are used as an antifreeze. They are used as fuel, etc., etc. Now let's move on to alkanals and alkanones. Alkanals and alkanols. Now don't forget this alkanol has this one we have it in form of RCOR. It can also be written as this. Or just take note of this because it will understand it will make you, it can also be written as this, but take note of this, it will make you to understand how to place the structure very well. So that's this one is for alkanol, while this one is for alkana, RCHO. But don't forget both of them have a functional group of C double bond with carbon. Both of them. Both of them. That's the similarity they have, their functional group. They have same functional group. But how do we get the different? I've explained earlier. For the different, how to know the difference since they have both same functional group. This one will be on the middle for alkanols, while it will be at the terminal for alkana. Are we together? Now preparation. Preparation. So now there is no let me say okay now before I move to that, let me start with RCOH. We have hydrogen in the presence of Cr2. I hope I'm not been writing C2 before. Cr2, let's say H plus here, to give us RCO. We've done this earlier, I think so. This is a primary. I've done it under this place. I've done it. The preparation, how do we prepare them? Oxidation of alkanol. The primary oxidation of alkanol will give you alkana. Can back the video and go and do this because I won't stay longer on this. Preparation of alkana and alkanol. We prepare alkanan by the primary oxidation, or let me say partial primary, by the oxidation of partial oxidation of primary alkanol. Because if you oxidize it again, to give you alkanoic, I've explained earlier. So maybe incomplete, let's call it incomplete oxidation. If you oxidize this primary alkanol, you get alkana. But if you oxidize secondary alkanol like something like this, maybe you have this is R, then you have your OH. Don't forget this R contains C, this one also contains an alkyl group. So this one is going to give you your catalyst here, this thing. This one is going to give you RCR, then you have your O. So that's that for that. Now let's talk about now take note. If you use Cr2O7, it's going to change the color from orange to green. The difference between the two catalysts. If you use Cr2O7, it's going to change the color from orange to green. If you use permanganate, MnO4, is it minus now? I think so. It's going to change from purple to colorless. Take note of the difference. When we are doing blah 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 and we use this thing, the color is going to change from what to what? Orange to green. Orange to green. See, you have to cram in chemistry. So this guy will change to purple, yeah. Purple to colorless. So that's that for that. Now another thing, let's talk about their physical properties of. So they have high boiling point, and their low members are soluble in H2O. Their low members are soluble. And don't forget, none rather. Where is it? Alkanones. They don't. They are the least alkanon is propanol. Yeah, we don't have methanol. We don't have ethanol. So the list is propanol. Are we together? Why? Why is it propanol? The question you should ask. Now, I told you for an alkanol, you get alkanol from the oxidation of secondary alkanol. You get alkanon from the oxidation of secondary alkanol. So now that means the alkanol itself must be in the form of secondary alkanol. That is, the OH in the secondary alkanol, is not attached to the terminal. It's attached to the middle, such that the carbon attached to it is directly attached to two carbon. Something like this. See this one? There's a carbon here, maybe C something. This RQ group, it has a carbon. So the carbon attached to this is directly attached to. Are we together? So for you to have an alkanol in form of this guy, we have C here. So let assume that that's is CH3. Then we have a C double bond O. Then we have another CH3. This is propanol. You cannot have less than 3 carbon for alkanol. Because if we put H here and not carbon again, if we put hydrogen here, it's no longer non. This is al. This is ethanal. Do we even have ethanal? Yeah. This is ethanal and hydride. This, yeah, we have. Don't mind. This ethanal. It can be ethanol. Why? Because it has to be in form of the secondary alkanol that we oxidize, such that two carbons are directly attached to the carbon carrying the OH. So here we only have one carbon directly attached to the carbon carrying the double bond O. So which is in form of aldehyde, alkanal. For it to be a ketone, which is same thing as alkanon, another C must be here. So the least member of ketone is propanol. Are we together? So that's what I want to take note of. So now let's continue with the physical property. The low members are soluble in water. The low member like the propanol, probably butanol, the low members in the family, they are soluble in water. So methanol, the properties we are discussing them together now. Methanol and ethanol, not none now. Methanol and ethanol, they are gases at room temperature. They are gases at room temperature. Though majority of the simple alkanal, the simplest one, like the simple one that doesn't have much carbon, though we say methanol and alkanal, they are gases at room temperature. Yet majority of the simple one, you may think like since this one are gases, then probably those simple ones should also be partially gas. No, methanol and ethanol, they are gases, but the majority of the simple one, even this story I'm saying is not necessary. Just know methanol and ethanol, they are gases. Majority of the simple one, they are what's it called now? Of the simple alkanal. And nons, they are liquids. Majority of the simple members of alkanon and alkanones, please take note of the two. They are liquids. So they also undergo oxidation. They undergo oxidation, but take note, for the alkanal, we can oxidize alkanal to give us alkanoic. When we oxidize alkanol, that incomplete oxidation give us alkanal. So we can also oxidize alkanal to give us alkanoic. I've done those one earlier. So now, if we oxidize alkanal to give us what's it called now? To give us alkanoic. I'm sorry if I've said something that shouldn't be. I can't remember what I said. But take note, alkanol. We oxidize alkanol. I've said it earlier. Primary alkanol to be precise. Incomplete oxidation of primary alkanol to give us alkanal. The property, what we are discussing now, is the property of alkanal and alkanol. So incomplete oxidation of primary alkanol give us alkanal. So now if you now oxidize the alkanal, we get alkanoic. I've said it earlier. I did everything together. So if you now oxidize the alkanal we derive from the oxidation of primary alkanol, we now get alkanoic. But what of alkanon? Alkanon is not easily oxidized. Like, no easy oxidation for alkanones, for ketones. No easy oxidation. But if we force them to be oxidized, they will give us two acid. For instance, if you have RCOR, none, you force this guy to be oxidized, you will have RCOOH plus another RCOOH. Are we together? So like it will produce two acid. Unlike alkanal, if we oxidize it, you only get one acid. but for none, you get two acid. So that's that for that. Now let's talk about the test. Since these two things are almost studied together, like it's very rare to see. In fact, any teacher teaching Alkanal and is not teaching Alkanol with Alkanal is not done. Alkanal and Alkanol should be treated together because they have similarities. So that when treating them together, you state their similarities and their difference, which we have been doing. So now let's now see when there is an Alkanal compound and Alkanon compound, how can we differentiate the two? How can we know that, oh, this is the Alkanal, this is the Alkanon, this is the IDI, this is the ketone? Now we have two tests for them. Two tests. Number one is Fellings test. We have the Fellings test, which contain copper 2 plus. Fellings test, which contain copper 2 plus. Please don't mind my writing. I'm very sorry. Copper 2 plus. So Alkanals change the color of Fellings solution from blue to brick red. Blue to brick red. Alkanal, but Alkanol doesn't. Are we together? So Fellings test that contain copper 2 plus. If you put an Alkanal into it, the color of that Fellings will change from blue to brick red. So when maybe you a Felling solution, you put it in two cups. You now put Alkanon here. They gave you two compounds. Are we together? One is Alkanon, one is Alkanal. You put the Alkanal in that Felling, distinct Felling solution. You put the Alkanon here. Anyone that changed to blue from blue to brick red, that one is Alkanal. But for Alkanol, it doesn't. Same thing with Tolling's reagent. Tolling's reagent. Are we together? That one contain complex ion. Complex ion like argentium, silver. I'm calling the Latin name silver. Silver. Then we have uh, NH3 di rather NH3 2. Then we have plus. So this is a complex ion now. It contains complex ion, that tolling reagent. Now what will happen for tolling reagent is that sorry. So for Alkanal will gives a deposit of silver. Nals, Alkanals. Don't forget for this one, Alkanals, blue to brick red. But for this one to give a deposit of silver. When you say deposit of silver, you know that's now, but nons, it doesn't. That's that for that. Now let's move to esters. Esters, or you call them Alkanoates. Are we together? This is their pattern RCOOR. The difference between this and none is that this one is 2O. This thing is not clear. I'm sorry. Okay, now it's clear. Thank you. For none now we have RCOR. For noate we have RCOOR. Are we together? So the carbon is attached to two hydrogen for esters. Alkanoate. Now esters are derivative of alkanoic acid. They are derivative of alkanoic acid. They are also called carbonyl compound. Carbonyl compound. They are called carbonyl compound. So why do we call them carbonyl compound? Any compound that have a double bond with oxygen, they are known as carbonyl compound. Are we together? With double bond to oxygen, where the carbon have a double bond with oxygen, they are known as carbonyl compound. So now we have I think did we discuss, okay, it's not here we discussed that. Let me check. Okay. Did I touch any reversible reaction here? Actually, yeah, I discussed that under yes, under sorry, I'm just trying to check if we have done that. Yes, yeah, this is it. Esterification. You know that esterification is a property, that's what I'm looking for. Properties of alkanol I discussed earlier. Esterification is part, and I told us how the reaction of the esterification will be, and I said is reversible reaction. When you have alkanol and alkanoic, it will give you esters. Are we together? Esters and water. So now we have now gotten to the ester. That's why we call them derivative of alkanoic acid, because we obtain them when we have an alkanoic together with alkanol. We obtain ester. That's why they are being called derivative of alkanoic acid. Are we together? So that's the reaction. We've done it earlier. Okay, let me just rewrite it. We have alkanol plus alkanoic to give us alkanoate plus H2O. Are we together? Okay, let's start. Let's use ethanol. OH. H plus let's use propanoic. O. Then we have OH. Propanoic is R a, alkanoic. They are in form of RCOOH. RCOOH. Are we together? So to give us reversible reaction, this one will give us, we are going to have C, C, C. This one have a double bond with O. Then we have another O. Then carbon, carbon. Then we have what else? Then we have H H H H H. This one cannot take H H H H H H. So RCOOR. The one that is attached to the oxygen with single bond with carbon, that one is the alkyl, ethyl. The other one is the noate, propanoate, 3 carbon propane, propanoate. Are we together? So that's that for that. Now we also have some properties. Let's talk about their chemical properties. This one is preparation. This one we just did is like the preparation of alkanoates. Now their properties. They have the reverse of this guy. The reverse of this guy is called hydrolysis. So they have hydrolysis properties. That is, if you add water to them, they will give you alkanoic and alkanol. That's one of their properties. Reverse of esterification. This one I drew is esterification. The reverse is hydrolysis. Are we together? So another thing you need to know is that what is it called now? So how do you know? I want to give us. Okay, I'm sorry. I'm just trying to. So now, okay, maybe when I remember, I will pick it out. Are we together? I'll pick it out. So they also undergo reduction. Reduction, like one of their chemical properties, also reduction. Reduction, and another one is also we have reaction with ammonia. That reduction, they are reduced by a strong oxidizing agent, which you must not forget. That Li, layer H4, Al, lithium tetrahydroaluminate 3, if I'm not mistaken, H4, to give alkanols. That is, alkanoates are reduced. One of their chemical properties is hydrolysis, reverse of esterification. This is esterification. Just reverse the thing, you get hydrolysis. Now reduction, they are reduced by this guy. It's a very strong oxidizing agent. Even there are some compounds that they don't want to be reduced, but when using this guy, compound like carboxylic, there are other reducing agents that carboxylic cannot be reduced if you use them. But when you use this guy, they are reduced because it's very strong. It's a very strong oxidizing agent. Please take note of that word. Very strong oxidizing agent. That's such that some compound that they are very stubborn to be reduced, this guy will reduce them. So this guy reduce esters to give alkanols. It reduce esters to give alkanols. Please take note of that. So their uses, we have their artificial flavoring of food. Are we together? Artificial flavoring of food. And when we reduce it, let me not forget, when we reduce it, the alkanol that is produced most of the time is ethyl ethanoate, ethyl ethanoate to ethanol. Like what we reduce rather, what we reduce, this reduction, the kind of ethanoate we reduce, ethyl ethanoate to give us ethanol. Ethyl ethanoate to give us ethanol. Most of the cases, we reduce ethyl ethanoate to give us ethanol. So their uses now, we have the artificial flavoring of food. We also have they are used in perfume, their scent. Are we together? They are used as solvent of paint. Paint, they are used in perfume and cosmetic, etc. etc. We have more. So now, without wasting much of our time, let's move to carboxylic. So yeah, I'm coming minutes. Okay. So carboxylic, another word for carboxylic, they are also known as the alkanoic. I don't have to be telling us preparation. How do we prepare carboxylic? Reduction of alkanoate, you are going to get carboxylic this thing. So most of the things, that's why I did these five together, or four: alkanol, alkanone, esters, yeah, and carb. I did them together because the preparation of one is linked to the other. If hydrolysis now, you get carboxylic, so I won't waste much time on the preparation. Am I communicating? So another thing I will show us is that um for Alkanol, we have classification based on numbers of OH, dihydric, monohydric, tri-poly, and based on position, primary, secondary, tertiary. So for carboxylic, we also have classification. So we have based on number, we have the monocarboxylic, we have the dicarboxylic, and we also have tricarboxylic. The monocarboxylic is just like ethanol. Mono, we have like C, sorry, COOH, COOH. We have another H here. So that is, we only have the COH. This carboxylic is in form of RCOOH. Anything you see in this form, where this R is an alkyl group, don't forget. So we only have one carboxylic attached to a carbon. So, and because the carbon are now two, because this is a functional group of alkanoic, it doesn't mean uh, this one has made it alkanoic. Then this, since we have only one carbon layer, it should be metanoic. No, 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 no. You are still going to you have to count this carbon. So this and two, ethane, ethanoic. Are we together? So examples of monocarboxylic is ethanoic. So we also have dicarboxylic, carboxylic. We have something like COOH, COOH. This one is because we have two carbon, it's going to carry the name like ethane. But this one will give us ethane dioc. Dioc. This is alkanoic. Oic. Because we have two dioic. Are we together? It's an example of dicarboxylic. You can also have another dicarboxylic. This that one is cis butanoic, butane dioc rather. That one will give you double bond, butane, not butane. COOH, then COOH. This one is known as cis butane, butane dioc, cis butane dioc acid. Yeah, sorry for my writing. So examples of this dicarboxylic we have two examples of we have done mono. Now examples of tri. Examples of tri are the citric acid. That is the acid in citrus. Citrus species. Those of you who did biology, like all these orange, grapes, lemon, lime, whatsoever, anything orange form, they are citrus. They contain citric acid. So they are examples of tricarboxylic, whereby you have COOH. You have another COOH. You have another COOH. Are we together? So they are citric acid. Citric acid. I'm sorry. citric acid. So this generally this is citric acid. So please you have H. But the name of this compound, like whenever you have tricarboxylic, they are found in citric acid. But the name of this compound, if you want to name it, it's going to give us I'm coming. Maybe I think we are going to have one. Let me put OH here. Yeah, OH. So this guy is going to give us 2 hydroxypropan 1, 2, 3 tricarboxylic acid. Yeah. Assuming I don't have OH here, maybe it's just H. It's because of the citric acid I mentioned, because they are also going to contain OH this thing. It's going to contain hydrogen. Assuming I don't have hydrogen here, it will just give me propan 1, 2, 3 tricarboxylic. But so far I'm having this. Oh, please wait. Sorry, it's not. We have H here. Sorry, this H. So the OH is here. Sorry. Yeah, that's where the OH is. Yes. So because if you want to number 1, 2, 3, are we together? 1, 2, you number like this, whichever way you want to number. So that's that. So this is where the OH is. Either you want to pick this chain, that's 1, 2, 3, 4. Am I communicating? You start from here to be 1, 2, but you can't skip this carbon. You have to count it with it. So here this one will give us 2 hydroxy, 2 hydroxy propan 1, 2, 3 tricarboxylic acid. Are we together? So that's that for that. Now properties. Let's talk about their properties. Um, Properties of carboxylic acid. Now the carboxylic acid with low molecular weight, they are highly soluble in water. The one with low molecular weight, that is the one with less carbon. I'm talking of low, the one with 10 carbon. If you are comparing it with the one with 2 carbon, you should know that the one with 2 carbon has lesser weight than the one with 10 carbon. So the one with low molecular weight, they are soluble in water. So you can deduce that their solubility increases as the number of carbon in them decreases. You can see it in that form. Solubility of carboxylic group acid increases as the number of carbon decreases. Solubility in water. Yeah, because they can form hydrogen bonds with H2O molecules. Are we together? But as the hydrocarbon chain becomes larger, so their solubility in water also decreases, like I said. So same reason for this guy. What's the name? I can't remember. Let's just move on. So we also have don't just say um what's it now? Though actually solubility increases as the number of carbon decreases. But it doesn't mean that as you are decreasing the number, now solubility will what? Decrease, abi, as the number of carbon increase. That's the reverse, which is also correct. If solubility increases as number of carbon decrease, that means solubility will decrease as number of carbon increases. So there are, if now you can get to a point whereby some are not soluble in water. It doesn't mean because we mentioned decrease, then and it will just be becoming smaller. There are some that are not soluble in water. Are we together? Just like benzoic acid, the guy is not soluble in water. Are we together? So we have the one with number 1 to 3 carbon. The number one metanoic, ethanoic, propanoic. Are we together? The 1 to 3. Do we have? Yeah, we have metanoic. We have. Yeah. This COOH. I think H. I think we have metanoic. Those 1 to 3, they are liquids. Please take note of them. And the 4 to 9, the one with 4 carbon to 9 carbon, they are oils. They are in form of oils. While 10 and above, the one with 10 carbon and above, they are solid. Sorry, solid. Are we together? Please take note of that. So also they are this thing. Their boiling point. Their boiling point increases as the number of carbon decreases. Their boiling point increases as the number of carbon decreases. Yeah, sorry, I just have to confirm something. So their boiling point increases as the number of carbon decreases. And note, the hydrogen bond involved in carboxylic, the hydrogen bond there is intermolecular. Take note of this thing. Please, just bring it out from my words and put it down. The hydrogen bond involved is intermolecular, not intra, not intra. So this one is, they are inter and not intra. Take note of that. So the preparation of, we have done the preparation. Now let's move to preparation of alkanoic. We've done them. Oxidation of primary alkanol to give you alkana. Then oxidize the alkana to give you carboxylic. I've done it earlier. Are we together? So that's that for that. And in the presence of this reagent, um this inorganic catalyst KMNO4 or K2CR207, and note, in acidic medium, not basic medium. Take note, the reaction take place in acidic medium. That preparation of carboxylic, whereby you oxidize primary alkanol, like I said earlier in the video, whereby you oxidize primary alkanol to give you aldehyde, or which is also known as alkana, then oxidize the alkana to give you um, carboxylic. The presence of this reagent, inorganic catalyst Cr2O7 or KMNO4, in acidic medium. Take note of this thing. The reaction take place in acidic medium, not basic medium. Please take note of that. So are we together? We can also have them. We can also produce them. The hydrolysis of esters, esters. The hydrolysis can be, it can be basic, it can be alkaline hydrolysis, it can be acidic hydrolysis, like the reverse of esterification. How do we get ester? It's when alkanol combine with alkanoic to give you alkanoate and water. The reverse is hydrolysis. Are we together? But in this case, we're also talking of the same thing, the hydrolysis, but this hydrolysis can be alkaline hydrolysis or acidic hydrolysis. Am I communicating? To give us um carboxylic, are we to get carboxylic acid? We can also prepare them by that. I've given us similar stuff when we're dealing with those initial topics. Am I communicating? So we can also have them by hydrolysis of acid derivative. Hydrolysis of acid derivative. Hydrolysis of acid derivative. Then we also have I think that should be all. So that, let's move to alkanoic derivatives. Alkanoic derivative. We have the acid halide. You can also call them acyl halide. That is what we can derive from alkanoic. You can get the acid or the acyl halide. You can also get the acid anhydride, acid anhydrides, acid anhydrides. What else? Let me remember that third one. Oh, I think, okay, yeah, amides, acid amides. You can also get esters. Yeah, don't forget, when you have alkanol plus alkanol, you get esters and water. So that's that for that. Now another thing we move to is no, it's also carboxylic, but we just want to continue moving to their properties now. Properties. I think we've discussed on properties. Okay, sorry. That's properties already. Okay. I think that's all I can remember. Let me think if there, before I end the video, let me think if there are other things to add to it. Um, have I talked about the reduction? Yeah, I told you they are not easy. Carboxylic are not easy to be reduced. Yeah, I remember some other property. They are not easily to be reduced, but with the presence of this guy is very mad. LiAlH4, Lial H4, Leal H4, whatever you want to call it, tetrahydro, lithium tetrahydroaluminate 3. So we can reduce them by that. So whenever you have what's it called? RC, yeah, RCOOH. In the presence of this guy, LiAlH4, you are going to get ROH plus H2O. So that's their reduction. Are we together? Not easily reduced, but you see this guy. The other reducing agent that we have cannot reduce this to, what's the name itself? I've forgotten. But using this guy to reduce, this guy is really mad. I'm trying to remember other things. Uh, yeah, another properties we have is oxidation. Is oxidation. Yeah, they are not easily oxidized too. They are not easily oxidized. Do you know why they are not easily oxidized? Because we oxidize alkanal, alkanol to give us alkanal. We now oxidize, and we call that one incomplete oxidation. We now oxidize alkanal, add the idea, to give us alkanoic. So that means like we've done the complete oxidation. So that's why this guy, though he still have a property of oxidation, but they are not easily oxidized because it seems just like nothing to oxidize. But if you force them to be oxidized, for instance, maybe if you have metanoic, yeah, they are not easily oxidized actually, but those ones that at least you can still oxidize, they are the what's it called? The metanoic and the ethanoic. Because they are product of oxidation. Yeah, let me put it that way. They are product of oxidation, like a complete oxidation of alkanol. Incomplete give us na alkanal, then by oxidizing that again, we get alkanoic. So they are not easily oxidized, except for two, which are metanoic and ethanoic. So when we oxidize metanoic, we get CO2 plus H2 gas. Are we together? When we oxidize ethanoic, we also get CO2 plus H2. This is also gas. But this one will give us double CO2 gas because this one contains double carbon gas. I think that's that for that. Another property is also, yeah, dehydration. Dehydration. For the preparation, I think I've told us the preparation. So I'm kind of tired. There are things I missed that I should have said. But I can't. I think, well, just if you are able to just know all this one, let me see. Let me just see what I can do. Maybe I can just snap, um put it this way. If you can just screenshot it like that. Is it clearer now? Come. Okay, we did not start here. So you can have it this way. Oh my god, this thing is not clear. It's not clear. Oh god, sound now. See, can screenshot it that way. Because I'm making video like that and it's eating on my space. You can screenshot this too. You can screenshot this too. But the main thing is that you just follow what I've said. Like, follow what I said. Maybe you should play the video again as I'm speaking, be writing. So if you are writing as I'm speaking, in fact, the note you will have will be more than, because there are things I said that I did not even write down, which will help you. So thank you very much. Wish you success.